Okay, scales, coordinates. Let's talk about them. So far, we've defined the aesthetic mappings that specify which perceivable aspects of the plot correspond to what variables. However, there are more perceivable aspects of the plot, and these can be mapped to variables in tons of other ways. So, for example, say we have a categorical variable. I know this is super creative. That takes values A and B to the color aesthetic. That means that the color is going to represent whether a variable took the value A of B or B. Now, great, we've got a way to distinguish between those key points, but after that, we can do practically everything to assign our colors. We could map red or A to red, black to B, map A to green, B to blue, A to purple, B to gold. It's infinite. Utterly infinite. Every combination you can think of. And then all the combinations you didn't think of. You get the idea. It's infinite. So now ggplot has good default mapping for the aesthetic space. But sometimes you'll want to adjust these by hand. So to do so, you can use the scale function. Now in the old version of ggplot, the version that I was raised on, had really poor mapping for continuous values to colors. It was awful. And a lot of folks used the Vertis color scheme, which at the time was not the default. It was its own library and you had to like manually do it because it was helpful for distinguishing continuous information for both continuous values as well as ordered factors. So it's become the norm. But back in my day, when we walked up the hill to school in the snow both ways, and insert the rest of that weird idiom here, ggplot wasn't as glorious and well supported as it is now. It's really great now. I mean, it was pretty good then, but yeah. Data science being a thing and having become into its own in the past decade has really allowed ggplot to be, and all of our studio to be, financially viable enough that they've been able to invest in that package infrastructure. Okay, enough about my ramblings in ggplot. Let's talk about the coordinate system. So I already gave you a kind of a teaser of some fun ones, but you can specify what the coordinate system is independent of everything else. Typically, we're talking Cartesian. That's the default, so that's like X and Y plane. And that's almost always what you want, pretty much always. A coordinate flip is kind of useful sometimes. For example, a box plot requires that its explanatory variable be mapped onto X. So maybe you want a horizontal box plot, so you flip it with the coordinates. Or maybe you've got a lot of stuff already programmed in, and then at the end of it, you're like, flip these for aesthetics. So instead of having to reprogram all of it, you can just add chord flips, and it does it for you. It's great. So coordinate polar will totally make your plots look cooler. That's what the all the swirly ones are. It's the most difficult to read and it is almost never helpful. Like ever, ever, ever. But it looks really cool. So if you want to design a plot to be deliberately opaque but super pretty, then polar coordinates are for you. So that's scales and coordinates. Faceting, which is fascinating. I went there. So, what faceting does is it allows you to make multiples of your plot. And other grammar and plotting systems tend to implement faceting with a fancy coordinate system, but it turns out it's way easier if you just think of them as separate entities. Um, So if you think of each facet as its own separate plot that you like smushed back together, it tends to be easier. So each facet is essentially a subset of the data, and it takes that subset of data as its input and whatever variables you use to make the subset, and that's how it lays out the subset. That's it. Instead of having to like partition the data like after you've it's just way easier to think about it like you sliced it up and then you just did the same plot with all the slices. Yeah. Now, so for faceting, there are a couple options. One, or how you wrap it. So facet wrap lays out the plots for each subset sequentially. So they just go like 1, 2, 3, 4, 5. It's very exciting. In theory, facet grid should be its own line. Nah. Alright, well, guess what we're gonna do? We are gonna fix this because I will not remember to do it later. Okay. Spoilers. Let's find that stupid thing. Because it's gonna drive me nuts. Okay. So we got a couple of those. Oh, that one is fine. Oh, here's the first one. Very cool. Okay. Cool. And oh, that one was fine. Coordinate 4, I think was fine. Oh, yeah. Maybe? No? Nope. Oh, we're close. Come on. Alright, let's see if re-rendering it helps. Sometimes Markdown doesn't do what I want. But usually it's pretty great.
That was fine. Coordinate looks fine. It's the third one that's not fine. How about we change this?
This guy? Nope. Maybe? Nope. Okay. That's working. Great. We're not touching it again. No, there was a... Yeah. Okay. Fun facts that you can now see behind the scenes. That even I, your intrepid guru R lady, makes mistakes in R that I don't catch until it compiles. Oh, that's stinky. Come on. Yeah? Nope. Okay. I give up. Let's just go back to the full view, because... Cool. So yeah, facets. They lay out... So when you use facet wrap, it lays out the plots for each subsequently versus facet grid, which subsets the data in accordance to 2 separate variables. So it gives you like a whatever your two. So if you've got 2 groupings, it's 2 by 2. So 4. It's great. Hello? Why is it being dumb? Okay. Let's go back to viewer. Okay. Now it's working. Great. Ah! Coordinates are not working. Alright. Well, faceting works. So let's just... Okay. So the facet position... Let's just do this whole slide again. Okay, so facet options. We got facet wrap, we got facet grid, and then we got facet position, which... or no, that's also facet grid. So for facet grid, The x-axis represents levels of one variable, and the y-axis represents the levels of the other. Cool. I'll see you in a bit.